I'd like to ask you a question. What are some of the things that we might do if the vCenter server, the hub, if you will, for managing our vSphere environment, fails to respond? And in this nugget, you and I are going to take a look at answering that question together. Houston, we have we have a problem, and it's a real problem. I launched the lab and it wasn't functioning, so I thought to myself, okay, what did we do? And in reality, we did a lot of stuff. We removed fault tolerance for a VM. We moved ESXi 2 and 3 out of cluster 2, and we added them to cluster 1. And then we set up vSAN. And as part of that, we modified the VM kernel adapters on each of the ESXi hosts to enable the vSAN traffic on those VM kernel adapters. And then also, because ESXi 1 was running out of memory, I added 4 gigabytes of RAM. I was complaining that it was almost out of memory. We saw those alarms going off in the previous nugget on vSAN. I also took the liberty to add some additional fault tolerance to add another VM NIC to each of the ESXi hosts that is connected to our vMotion network. And the reason I added that additional interface was because we're using that vMotion network not just for vMotion, but also for fault tolerance logging and also for vSAN. So I wanted to give it some more bandwidth so it could better support all that traffic. So I'm sure you'll agree that that's a bunch of changes that we made to our vSphere environment. And when I powered on the lab to do the next nugget, I usually wait several minutes, like 8 or 9 minutes, because I know that the ESXi host, ESXi 1 specifically, has to boot up. I know that the Windows server that's providing a lot of the iSCSI and NFS services has to initialize. And then on ESXi 1, once it's up, it auto starts the vCenter server appliance. And then once it starts the appliance, that takes 3 or 4 minutes on its own to fully initialize. And that's why I usually wait about 8 to 10 minutes after launching the lab to go ahead and log in and start working with it. Well, today, when I launched the lab, I waited the 8 to 10 minutes, and the vCenter server appliance is not happy, meaning it's not responding. So I thought what we would do, because we're going to have a bunch of troubleshooting in this course, I thought, why not do some live troubleshooting with our current situation, and I'll make it into a lab. So that's what we're doing right now. The vCenter server appliance is not responding, and we want to troubleshoot that. So we've just talked about the changes that have happened in our topology. And as far as observations go, I tried to open up the browser to the vCenter server appliance, and I got no response. So what you and I get to do right now is to figure out why, when we try to launch the vSphere web client and connect to the vCenter server appliance, find out why it's not working. And from a connectivity perspective, our Windows management station, which we're also using this Windows server for, is at .100. It's on the 192.168.1 network, and the vCenter server appliance is also logically connected to that same network of 192.168.1, with the last octet being .111. So here on our Windows computer, let's go ahead and launch the integrated scripting environment. There's an icon for it right here in the taskbar, the PowerShell integrated scripting environment. And it's a handy tool if we have commands that we're going to do over and over again. Even if those commands aren't natively PowerShell, we can still launch them from here. So we could create them here and then bring it back up if we ever need it. So in the scripting environment, we can put our commands up here, and then it shows us the results once we run them down here. And we can also choose to run those commands just one line at a time, which is what we're going to do. So let's test name resolution. Now traditionally, we'd use a tool like NSLOOKUP, which is a darn good tool. And the PowerShell command that can do that for us is called resolve. And then once you have part of the command in, you can do a control space on your keyboard, and it'll supply a drop-down of the options. So we want resolve DNS name. So we can use the up and down arrows to select the command we want, press enter, and it will complete it for us. And then we'll do a space and type in vcsa.nuggetlab.com. And then we can press enter to enter our next line. Now if we want to run just line 1, we can highlight that just by clicking the mouse to the left of that line number 1. And then we could click on this icon right here to run that highlighted text. Or we could press the F8 key and it will launch it for us. And this output indicates that the name resolution is working great. That is the IP address for the vCenter server appliance. And the more traditional command of NSLOOKUP space, and I'm simply going to copy paste the name by doing Control C with it highlighted, and then coming down to line number 2 and do a Control V. And we could highlight that row, row number 2, by clicking to the left of it and hitting F8 to run that. So even though NSLOOKUP is not a PowerShell command, we can still launch it here from the scripting environment. And the NSLOOKUP indicates that we're using DCNUG as our name server. This is our name server's address. and we're able to correctly resolve the vCenter Server appliance to its IP address. So we are not having a DNS problem as part of this troubleshooting lab. So next, let's go ahead and test for basic connectivity. Now we can do that with a ping. Ping works great. And we also have a PowerShell command to test connectivity. It's called test dash, and then there's a lot of options. So I'm going to type in net connection. We can press enter to auto-complete that, space, and then I'll do a control V to paste in the name of our vCenter Server appliance again, highlight that row, and hit F8 to run that. So among other things, it does a ping, and this is not looking too good. Let me scroll this up a little bit. So in the output below, if we scroll down a little bit, this shows us who we were trying to ping. It also had resolved it to this IP address. There's our source interface that we're sourcing the ping from on this Windows computer. There's our source IP address, and the ping did not succeed. So of course we could also use tools like ping. So we'll do a ping and a control V. And then with the cursor at the end of row 4, we can also press F8 and it'll run that command for us. And this confirms the same result as the test-net connection, that we don't have connectivity from our management computer over to the vCenter Server appliance. And the cool thing about doing this here in the integrated scripting environment is that we can save this. In fact, I recommend we do that. Let's click on the save icon right here. And let's save this as DNS and connectivity test. And then later, if we need to run those same tests again, we can bring this up and use these tools and make it very, very quick. So we'll go ahead and click on save. And then I'm going to go ahead and close the PowerShell scripting environment. The next thing we might want to check is verify that ESXi1 is up and running and reachable. We could try to ping ESXi1 at its management address of .101, or we could just launch from our workstation the host client to connect to ESXi1, and if that works, that verifies that the IP address is reachable. It also gives us an opportunity then to use the host client and take a look at ESXi1 specifically and the VM that's supposed to be running on that ESXi host to see what's going on. So back at our Windows management computer, I have a shortcut up here for the host client, which is going to take us to 192.168.1.101/UI, which is the URL that we would use to reach the host client on a specific ESXi host. So we'll go ahead and double click on that to launch it. And Chrome is saying, you know what, I don't trust the connection. Effectively, it doesn't trust the self-signed certificate that ESXi1 is using right now for this HTTPS connection. So if we click on advanced and then scroll down a little bit, we can go ahead and click on the link to proceed to that IP address of .101. So we're going to go ahead and do that because we know it really is ESXi1. And then we're asked to log in. Now, the login here on ESXi1, we're going to use the username and password that we initially configured on ESXi1 when we deployed it. And the username is root, and we'll tab down, and the password is our lab password. So we'll supply that and then click on login. And to give us a little more room to see everything, let's also bring our Chrome browser full screen. Okay, so here on the ESXi host, if we click on monitor over here on the navigator pane for ESXi1, this might look great to somebody, but what this indicates, basically very, very little CPU consistently ever since it was booted. This represents, to me, that the vCenter Server appliance is not running, because if this is when it was first powered on, which is when I powered on this lab, what we should normally see is we should see at some point it going up high like this for like 3 or 4 minutes while the vCenter Server appliance fully initializes, and then it should come down. However, I don't see that, and what I see is very low CPU as we track along here. Very low CPU ever since I booted this lab several minutes ago. So over here on the left, under virtual machines on ESXi1, if we click on the VMware vCenter Server Appliance VM, here it also represents that this is not running. We have an option to power on the virtual machine, which I recommend we do, but we should also find out why it didn't auto start. So we'll click on the power on icon. We'll get this vCenter Server Appliance up and running. And while it's doing that, let's right click on the vCenter Server Appliance over here in the navigator pane. And then here on the menu for that VM, if we hover over auto start, oh, check this out. I thought this is going to be off. However, it shows configure and disable, which implies that auto start for this VM, which we set up a long time ago in this course, is still enabled for this VM. So if we click on configure, it has the same settings that we gave it initially. I'm going to click on cancel, not change anything there, but what I do want to look at are the auto start settings for the ESXi host itself. So on the left side here, below host, let's click on manage to take a look at the properties of this ESXi host. So we'll click on Manage here on the left, and then we'll click on the System tab if it's not already selected, and then we'll click on Auto Start right here. And regarding Auto Start, it says, is it enabled? No. So it was enabled when we had it in Cluster 2, and through the process of us moving it to Cluster 1, the Auto Start feature on ESXi1 is disabled. So let's go ahead and change that. We'll click on the little pencil for Edit Auto Start Settings, and we'll simply click on Yes to enable it. And once it's enabled, if we click on Save, that would explain why the vCenter Server appliance never came up, because the VM wanted to do it, but the actual ESXi host wasn't configured to allow it. Alright, so now with that set, let's go back to the monitor option under the host. So as we look at CPU utilization, this is just the vCenter Server appliance waking up. It has not yet fully initialized. What we expect to see is that CPU utilization on the host, at least for this host, is going to go between 90 and 100% for 4 or 5 minutes while the vCenter Server appliance fully initializes. So now as we look at this graph, several minutes have gone by. We can see that it initially powered on the virtual machine. Well, we actually powered on the virtual machine, and then it started to fully initialize. It took several minutes for that. This is the vCenter Server appliance causing all the CPU usage, and now it's going down back to normal, which is a good sign that we should be able to now connect via the vSphere web client. And if we hover over this graph, it can show us the percentage of utilization for CPUs. So let's go ahead and test this. So because I'm in full screen, let's do an F11 to go ahead and take us out of full screen for Chrome. We can go ahead and close this window with the ESXi host client, and now we can go ahead and double click on the vSphere web client, and now that that VM is powered on and fully initialized, we should be able to log on. So we'll go ahead and put in the administrator at nuggetlab.com for the username, and for the password we'll put in our lab password and click login. And while that's processing, I'm going to go ahead and bring this back full screen. And I'm going to rearrange my desktop just a little bit to give us more space by using the little pin option here. So we've minimized recent objects, recent tasks, and also work in progress, and also the alarms. So they're off to the side and bottom. We can still get there if we just click on them. And with cluster 1 selected, it shows us the summary for the cluster. And if we click on ESXi1, I'm interested in the CPU and memory utilization on ESXi1 as well. So if we click on ESXi1 in the Navigator panel and then click on the Summary tab, we can see here that the capacity is 20 gigs because of the 4 gigs I added, and we're using approximately 16 gigs of that, so I'm glad that we added some additional RAM there. The other thing I'd like to do with you and I right here is let's take advantage of the extra VM NIC that I added to each of the ESXi hosts. So if we go to ESXi1, which we're already on, and clicked on Configure, and then under Networking, if we click on Physical Adapters, and if we scroll down just a little bit here so we can see them all, you'll notice that we have a new VM NIC 6 that is currently not being used. And what I'd like to do is associate that with the switch, which is currently supporting our vMotion and vSAN and FT logging. So if we click on the Virtual Switches option below Networking, and then expand this just a little bit so we can see all the switches. If we click on Switch 3, it's vSwitch 3 that we initially set up to use for vMotion, and it shows us right here in the graphic that VMK2, the VM kernel 2 adapter, is associated with that switch, Switch 3. And if we click on VM kernel adapters, here on VM kernel adapters, if we click on VMK2, we can verify that we are using that for vMotion, fault tolerance logging, and vSAN. So what we want to do is for Switch 3, we want to chip in, if you will, that additional uplink of VM NIC 6. So to do that, here with ESXi1 selected, with the Configure tab selected, we're going to go back to Virtual Switches. We're going to click on vSwitch 3, and then we have this icon right here to manage the physical network adapters connected to this switch, vSwitch 3. So we'll click on this little icon representing physical network adapters. Currently it's using VM NIC 4. We'll click on the plus symbol, and we'll add to the party the available VM NIC 6 by selecting it and clicking OK, and clicking OK again. And we'll repeat that process for ESXi2 and ESXi3. So we'll click on ESXi2 on the left. Still on the Configure tab for Virtual Switches, we'll click on vSwitch 3. Click on the icon to manage physical adapters. Click on the plus symbol to add an additional adapter associated with this switch. Select our available VM NIC 6, click OK, and click OK to confirm. And then we'll do the same thing for ESXi3. We'll click on ESXi3. Under Virtual Switches, we'll click on vSwitch 3. Click on the icon to manage physical adapters. Click on the plus symbol. Make sure VM NIC 6 is selected. Click OK. and OK one more time. And then down here in the graphic, it should visually represent that we've got VMNIC 4 and VMNIC 6 as uplinks on vSwitch 3. And vSwitch 3 has a VM kernel port labeled VMK vMotion, and it has a VM kernel adapter, VMK2, associated with that VM kernel port. And this VM kernel adapter, VMK2, is the one that's supporting our vSAN traffic, our vMotion traffic, and our fault tolerance logging traffic. So now that we've identified why the vCenter server appliance wasn't auto-starting, and we've corrected that, and we've also configured an additional uplink to support our vSAN and vMotion and FT logging, this will be the starting point for our very next nugget. And as always, I would invite you to practice what we've done together in this nugget in the provided hands-on labs. So I'll see you in the next nugget. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.